We set up this extra design session because we had some questions about the attribute injection, and also there's a lot of activity around install packaging. And since both of those are going to be focuses for the next sprint, it made sense to have some design discussions and get everybody on the same page so that we can divvy up the work effectively in the next 2 weeks. So we've been making some changes, and we had some discussions that I think really kicked us down the path of bar clamps being operating system packages, and using the install mechanisms for that, and then from there having deployment and post configuration and things like that. So making those changes I think is beneficial in its time. So I wanted to, Victor, I was hoping you and I guess James and Ralph are some of the big proponents of it. So I was hoping to spend 20 minutes kicking around what we want to do, come up with some action, some ideas for action next sprint, and make sure that we all agree on the design objectives. Does that sound reasonable?
Mm-hmm.
Okay. So Victor, or is Ralph on? Yeah, I see him.
Yes, I'm here.
Okay. Well, Victor, you want to give an overview, and then Ralph chime in and talk about what you're thinking. I'll take notes and try and keep quiet, but hopefully we'll wrap it up in about 20 minutes. If not, if we need more time, we'll keep going.
So we've had several long-ish discussions on the public mailing list, and it looks like we do want to definitely move to packaging bar clamps up as OS-specific packages by default, and migrate away from using the current Crowbar bat install bar clamps that RB knows how to understand. And that is going to necessitate us having at least skeletons for the Debian control structures, or the Debian control directories, and a spec file for each bar clamp that we would then, or at least in the way I envision it, that we would then fill out with dependency information and other things like package names and whatnot from the Crowbar.yaml for each bar clamp. Since the Crowbar.yaml already knows about the package dependencies that that are required for each operating system, and the gem dependencies and the inter-bar clamp dependencies, we've already got all that information in a place that's pretty easy to parse out and throw into a spec file or throw into the Debian directory to generate packages out of. Okay, so, and the other questions are, how are we going to handle gem dependencies? Are we going to do something special to install gems? Are we going to automatically package all the gems that we need up as OS level packages? If so, how are we going to handle version conflicts like the stuff that we have right now? And how are we going to handle pre- and post-install actions that you handle at package install time versus at bar clamp install time? And the distinction I make there is package install time is when you just lay the file down on the file system, and bar clamp install time is when we have the Crowbar web app up and running, and it notices there's a new bar clamp and needs to do stuff to make it functional.
How do you want to classify those phases? So we have install time and post.
Well, I was classifying them as package install time versus bar clamp install time, but that nomenclature is a little confusing. If someone's got better nomenclature, feel free.
So one of the key concepts here is that bar clamps can be installed into a running system, right?
Mm-hmm. but we don't want to necessarily require that when we're just like laying down an admin for the first time.
So what is the minimum requirement? Expectation.
That's a good question. The distinction that I had in mind had a lot to do with if we need to do anything that might touch the framework, like require interacting with the framework,
Right.
it needs to happen at Barclamp install time. And anything that we know won't have to touch the framework, like just laying down files or laying down skeletonized databases, as in like SQL-like databases, we could potentially do at package install time. But if there's any doubt, I'd defer it to Barclamp install time.
So I'm assuming you're watching through my notes.
Yeah.
Right, this makes sense. What about installing the engine?
I don't know enough about how that's going to interact with the framework to be able to say. I mean, that'd really be a better question for Wayne.
Okay.
Wayne, are you on the call? Just figure it out.
So the engine installation does require that the WebMF be cycled because there's typically a migration involved and installation of routes, a route anchor, as well as the gem file change.
So an engine's going to bring in its own gems. Is that part of how we can handle gem dependencies?
In my mind, that's still an open question as to how we want to handle gem dependencies. I know OpenSUSE, they package all the gems up as OS packages. I don't know if we want to do that in the general case or not. Ralph, are you on? Can you jump in there?
Yeah, we had quite some discussions around that topic during the last weeks. But in general, we already did quite some of the packaging for the gems that are required by Crowbar, at least for the ones that are currently required. And for us, especially when talking about SLES-based products, it's generally a good idea to have the gems packaged as RPMs themselves, separate RPMs.
Yeah, my only real concern there is like right now we've got a situation where the chef spec tests that we have, they require one version of JSON, and Rails itself requires a different version of JSON, so bundler is flipping out. And I don't know how well Rails or how well that's handled in RPM in RPM land.
We handle that.
Yeah,
Okay.
I think so. It's possible to have two separate versions of gem installed at the same time.
As RPM packages, does RPM handle that case?
Yep.
Yeah.
Well, it might require some. Well, RPM itself handles that correctly. The problem is SUSE is probably with zipper, but even that can be fixed. Or it's a configuration issue of the zipper command line tool. So, yeah, that's handled.
Yeah, I know at the very least. Go ahead.
Yeah. Okay. We'll just it kind of depends on the concurrent versions that are required, and I mean basically, I've added a couple of links to the Etherpad, which go into great detail about all of this. But to summarize the basic approach, if the sort of the minor versions differ of the two gem versions that need to be installed concurrently, then that's generally not a problem because we're in the habit of suffixing. Like if you have version 1.1.2.4 and 125 that need to coexist, then that might be a problem. But if you have 124 and 134, then it wouldn't be a problem, because we'll typically suffix one of the packages with 1_2 to distinguish it from the 1.3 series.
Okay. And the other thing I was going to say is that if we're going to do the install packaging transition, it'd probably be a good time to go through and clean up a lot of the dependency crust that we've accumulated in the Crowbar.yaml. Strip out gems that we don't need as top-level dependencies, strip out LS-level packages we don't need as top-level dependencies, that sort of thing. Like, since we have one example, since we had a shiny new chef bar plant, we should probably move all of the chef packages into it instead of leaving them in the base Crowbar package.
Yeah. Covered. So I wanted to walk through the workflow, if that makes sense, in that to install Crowbar, where I had a start for this. Okay, so when we install Crowbar, Susan, I know you guys start from a working system, and so there's an assumption that the IP and name of the system is set. We actually our current install does a lot of this work, and we'll probably want to keep that from a regression perspective, so that people can start with an ISO and move really quickly. But I think what we're talking about now is that there'd basically be a yum or an apt-get install to install all the Crowbar components. Would we then basically do a single line that would include the bar clamps people want? What would the install look like from that perspective?
I would imagine that we can leave install chef as it currently stands, or at least the bits that lead up to actually putting chef and Crowbar on the box, more or less untouched. We just have to replace the stanzas that install chef and get it running, and the ones that install the bar clamps and bootstrap them with the relevant package install lines, and rely on the package install to do the bootstrapping they need.
Right.
As far as how we pick and choose which bar clamps to install, for now I just go with all the bar clamps that we need to, all the bar clamps that are currently members of any of the master builds in the releases, Crowbar, NTT, logging, that sort, and leave the rest of them for when you have things stabilized to make any further decisions.
So, I mean, one of the things that would be interesting from my perspective from a dev environment would be to snapshot a system, before we start installing the bar clamps, be able to upload the new packages, and then, just install the packages, have everything else ready. And actually, the package should also be effectively, should just be able to lay them down on top of an existing system for an upgrade, a simple one.
Yeah. Actually, there is another piece in here that I haven't thought about that I should have, which is what do we do with Sledgehammer?
Okay.
Is that going to be its own OS level package? Are we going to fold it into the Crowbar bar clamp? how are we going to handle that?
It's really part of the deployer, isn't it?
We currently in SUSE we handle this as a separate package. It's really an RPM which contains the image, and it's a separate RPM. It's not part of the deployer backend for us.
Okay.
And I'd probably say we should keep it that way, but well, it could just be a dependency of the deployer backend, of course. So that
Yeah, I mean, that's a good decision as well, right?
What did you say, Victor?
That's as good as a decision as any. And if Susan's already got it set that way, we may as well go with it.
Actually, I like that pattern because then we could follow that for other, potentially other OS deploys, right? Couldn't each OS that you want to deploy be packaged as a its own repository, its own package? So Ubuntu, SUSE, RHEL, whatever.
Right now, all of the logic that knows how to figure that out is folded into the provisioner. And there need to be some re-architecting to go to that model.
Okay.
Pretty much all the provisioner relies on these days is to deploy other operating systems. If you're in online mode, is knowledge of where the repositories to bootstrap the install from. And cross-live nodes, you still have to give it a whole ISO. So I don't see that you really gain anything by making that package-based.
Okay. My thought was more that it would be very straightforward to be able to use the install mechanism to bring it in and lay down the files that need to be in the right places. But we don't need to continue to go down that path. It's a little bit off topic.
Yeah, I mean, currently the provisioner takes care of that path for us.
Okay. Do we feel like we've resolved the... Go ahead.
Oh, I'm sure that we'll find out breaking things for our business as we go through this migration anyway, but, we'll figure it out.
That was my question was along those lines: is have we worked out the obvious issues that we need to make progress on this next sprint?
I think we have. There are some open questions. The build system, it pulls in a couple of just raw files and does things with them. For instance, the eLilo bootloader that we use to handle booting things in UFI mode. Currently, we just pull down a Crowbar that has precompiled EFI images, and we use that. There's the basic image that we throw onto Nova, and there's the stuff that we pull in for Tempest. I don't know if we want to try to package those individual bits as their own RPM or Debian packages, or fold them into the bar clamps that use them. But in my mind, those are less concerns for now.
Okay. I mean, those...
For SUSE, we would need to package those separately. But most of them, or at least what is needed for production setup, I think we all of have packaged already. Like the UEFI bootloader thing, I think there are already packages for SUSE.
Yeah, I mean, the eLilo packages are up to date. The only reason I pull them to Crowbar is because Red Hats are ludicrously out of date and don't work on the current system. So.
Yeah, I can imagine. So probably we need some way to, either we need to package those ourselves, or we need to some way to distinguish for what we build. And depending on if we build for Red Hat or SUSE, we need to pull in different things, or not to pull in things from Crowbar or SUSE.
Yeah. And in my mind, that it may just be easier to say that all dependencies like that, you need to generate, little RPM packages that in like the provision of ArcNet or whatever can depend on.
Yep.
Cool. All right. So our goal here was to be able to have enough discussion that we can move forward. So I think we've met that.
Mission accomplished.
Good. Okay. I'm trying to get Andy online right now.
Ralph, do you want to talk about the installation refactoring stuff now? Right time.
What exactly are you referring to?
The refactoring of install chef.sh to support our stuff.
Okay, well, that pretty much depends on the refactoring that is going to happen for the install process in general. It's not SUSE specific, so I'm not sure what makes sense. If it's a good idea to start working on installer chef, making it work on SUSE now, or waiting for the current refactoring to be in a state that at least some parts work again.
One thing that I just thought of that's not on this list that should be, on the development branches, there aren't any stands in any of the Crowbar.yamls for the SUSE operating system packages, like there are for Red Hat and Ubuntu. And that's having those there, which makes it a lot easier to standardize on how we create text and Debian files. Because then we have all the dependencies, the package dependency information in one place.
Yeah, sure. But I think Adam was referring to something different. It was regarding the...
He was. Yeah, that just popped into my head.
Yeah.
Heard what Adam's talking about.
Okay.
And as a side effect, that would let the CI system that I set up in Dell get a handle on, hey, I should also test all the changes that are being made on Tuesday as well.
Okay, yeah. There's one thing which I'm not sure about in the Crowbar.yaml files, how we should handle it with regard to packaging, and that is all the... the Crowbar.yaml files list all the packages that are required on the client nodes as well. How should we handle this with regard to packaging?
That's a good question. We may need to look. We'll certainly need to look into that.
I think ideally there'll be
Our model.
sections in the...
Oh, go ahead.
Ideally, I think there would be two sections in the Crowbar.yaml, one for the admin node requirements and one for the client nodes. Maybe three sections. You could have a common in there, I guess, if that makes sense as well.
Well, in my mind, it'd be what's required to deploy versus what will be required for the chef stuff to run. So, that's something we'll need to work out.
Well, right now, both on the nodes and on the admin, like if you look at Nagios and Ganglia, maybe that's the best case. If you look at the Nagios and Ganglia bar class, there have packages. Again,
right, but what I'm saying is right now in the Crowbar.yaml, it's all mixed together. What we need to install an admin node and what we need to, let chef pull in whatever packages it needs. And we need to split that out so we don't pull in stuff.
I think Adam is proposing a slightly different way of looking at it, which is not just chef client run, but a chef client run on the admin for Nagios, for example, will require one subset of packages, and a chef client run on a client node potentially will require a different set of packages. So I think, Adam, I'll let you make your point instead of making it free.
Yeah. Well, I mean, if we're using crowbar.yaml to generate spec, or at least update spec files, I don't know whether we want to generate them from scratch each time from templates and then insert the dependency data in, or just update what's there. But either way, we need to know. Yeah, we need a way of distinguishing which packages go on the admin node and which go on client nodes.
So are you thinking of a scenario where, given bar time, sorry, I joined late, so the repeating discussion that happens, are you thinking of a scenario where each bar time produces multiple SUSE packages, one to be installed, because they will need to have different dependencies?
Yeah, I mean that's certainly a use case.
So you would have, sorry, go ahead.
Well, the way I look at it is there's a difference between the packages that are required to install a bar clamp and the packages that the operations of the bar clamp will wind up requiring. And in the former case, we want those to be looked at as direct dependencies of the package, so that when you say apt-get install bar clamp whatever, it sucks in the packages that it knows it will need to deploy the bar clamp and install those beforehand. In the latter case, though, there's a list of packages that we know the bar clamp will need to have to do its operation. Those are just ones that we have to make sure are staged on our deploy access, but we don't necessarily require them to be installed. And we need to make sure that dependency is clear in the Crowbar.yaml. And right now it's not, it's just all mixed up. Because I generated that list by just reading through all the share parentheses and finding all the packages.
Just to give a concrete example for this, it's like if you install the Crowbar bar clamp, that one requires the Rails gem to be installed to be and that would be the direct dependency of the Crowbar bar clamp RPM or .ded package. But all the packages that are not direct requirements of the Crowbar application would be, well, just need to be present on the ISOs and in the channels that are later set up on the admin node, which are not direct dependencies of the RPM. So they might not need to be installed on the admin node.
Right.
This would be, for example, the Keystone bar clamp later on has some kind of a dependency on the OpenStack Keystone package, but that doesn't need to be installed as a package on the admin node, but only on some client nodes where the Keystone roles are deployed. Just to give, trying to give some examples. And currently there's no way to distinct this in the current Crowbar.yaml, I think.
Yeah, and I think we'll need to grow one.
Okay. So I'm gonna.
So one of the things, if we're done with dependencies, one of the things that was going on the mailing list was what's the best mechanism to execute the various install actions. Again, if you already settled that.
What I would, unless we, the idea of the script jig, I would hold, because we're not suggesting that as an implementation for this right now, and I want to make sure we talk about attribute injection, because that's the other thing we're working on next sprint, and I felt like we should.
One thing.
Yeah.
About in the previous meeting was talk a little about the jig infrastructure. And I was planning to write it out, but they got stolen into all kinds of other things.
Mm-hmm.
Would it make sense to spend 5 minutes maybe on talking the current plan?
Sure. Definitely. Because that'll map into the OpenStack Common. I want to make sure that we have at least 10 minutes to talk through the recipe pattern for OpenStack Common, because hopefully just why don't you just lead us there in your description, Andy?
Sure. So if we other than me and Rob, are other people interested in talking about this? Okay, then maybe we can talk about this.
Hey, this is Chris. I'm interested.
Yeah, Andy, don't take silence as it not being of interest. Let's spend a couple minutes going through it, because it's the core engine of how Crowbar is relating to Chef, and jigs in general.
So what's jig all about? So there's the really big picture, there's like the bigger picture and the minute picture. I'm going to start in the middle and not focus on jigs in general, but specifically the Chef jig, which is currently our primary design driver, but we are keeping an eye towards other very pattern jig implementations, like the script jig that it was describing. So the primary use case is you use Crowbar configs and instances to describe what you want to achieve. That is represented as active model records, record, whatever else wants to call it in this situation, and that's persistent in the database. Once you actually say apply, and you want to execute something, you effectively pass responsibility to the jig infrastructure. That is basically an orchestration engine that's responsible of collecting information from the database, transforming it into the appropriate format for the specific jig via subclasses for the specific jigs. In the case of Chef, that means extract the attributes from the node attributes, the config attributes out of the database, transform them into the appropriate roles, node roles. We're probably still not going to use environments. So update, do all the necessary steps that by the time the jig infrastructure invokes the Chef line run and node, it has all the requisite information to go and execute its run list according to what was configured in the Crowbar barcode instance. So that's the big picture. Does that make sense? Okay.
Andy, the thing that I would add in this, actually, are you going to step into attribute injection then, for how they actually push the data?
More steps.
You got it.
2 more steps into attribute injection. So a couple of the requirements that I think James was actually asking about is, in Crowbar 1, the state of the orchestration engine is actually mostly persisted in memory. So if you look at deploying any non-trivial bar clamp, there's a sequence of steps that need to be orchestrated. Like my canonical example is Swift. In order to fully deploy Swift, you need to first run the Swift storage role on all the storage nodes, and then discover what disks are available and populate the discovery information back into Chef. Then go and build the ring file based on the discovered information from all the storage nodes, and then push that out, and only then can start the processing. So this dance of here's what the barcode needs me to, which roles the barcode needs me to execute in which order and which nodes, is currently only maintained in memory. So if the Crowbar web app crashes, then you will eventually get there because Chef will drive eventual consistency, but that's not the way we want to do it. So there's a cool gem out there that's called delayed job. One of its nice features is it allows you to persist into the database in a very seamless way, but just saying, do this later, do this now, but through your mechanism. Persist basically serialized information about what needs to happen and when, if you choose to use time delays. And have a separate process that basically executes those tasks based on what it reads in the database. You control the timing and the number of workers and all kinds of fun stuff like that. So that's how we basically maintain the set of registration engine where when you hit apply, we create a sequence of events and runs. Event is I'm going to apply this proposal. Runs is basically the set of orchestration steps to be executed on each node that's pre-computed, and then have those be executed by the late job executor that basically reads the database and does the right thing. What is the right thing, and that's where we get into attribute injection. One of the things that I think we talked about in the previous design meeting was search in Chef is very powerful, but also somewhat very broken. It works very well in eventually consistent environments, but if you're trying to do orchestration and be prescriptive about, I'm executing this now, I better have this succeed now, it doesn't work well with search because search indexes are updated very lazily. So if I take the Swift scenario where I just deployed 10 storage nodes and each had 10 disks, all that information is pushed into the Chef belly, and sometime later when you do a search on a node with more than 2 disks, you might actually get results. But it's very indeterminate how long does it take to set. But effectively there's a Solar indexer that does a full text indexing on data on all the nodes, and that takes a while. So in the Swift deployment scenario, if I just finish deploying all the storage nodes and I want to do the ring computation, it's likely to not be accurate because it will get some view of the information that Chef processes, so-called. We've seen it fail many times. Where does attribute injection come in? Well, we don't really need to do search against a full text index version of the node because we have all the relevant information in our database. So when we go and say, Chef, run Chef client on this node, at the end of the execution, there's a report handler that gets executed that collects all the information and all kinds of goodness, pumps it back into Crowbar. Crowbar digests it and shoves just the relevant parts into the database. And I think we spent time in previous meetings on the inbound attribute path, which is basically from the report handler up until there are records of the database. The reason they're useful is because on the outbound path, what we can do now is, for example, when we say, compute me a ring, so the ring basically has every disk that Swift will use with an IP address and port number next to it, so Swift can access it. In the current recipes that we have, we basically use Chef search. In the attribute injected variant of the recipes, when we will build the ring, it will be based on attributes that Crowbar injected onto the node before the recipe ran that has all the information as queried from the database. That gives us a much better consistency story, and it also lets us collaborate with other folks that deploy Swift because they might have other mechanisms to do the computation that Crowbar does. They might actually be happy with search and have another recipe that does the search and populates the same set of attributes that the actual Swift recipes will utilize to deploy Swift. Or for that matter, any other OpenStack components. We have very similar problems in other components. So to circle back and make sure I made the big points, be consistent, don't do search against the really, really bad index, and better collaborate with other folks that on the core of the OpenStack components, the recipe components, are the main two features or capable benefits that this attribute injection kind of gives us.
Right. So, Andy, I pulled something.
Any of that makes sense.
I pulled something up on screen to try and add something very concrete to what you said. And I'll point out that we're recording this, and Andy is giving a lot of deep technical process stuff that is worth reviewing. So, if I would recommend at some point, if you want to try and suss this out, that
I will
be a resource.
One of my sprint tasks is actually to document some of that and actually start implementing some of that. I've been sworn into supporting random other things, so I haven't gotten to it, but
Understood.
there will be a dev guide doc page that describes this sometime very soon, I hope.
Yeah, and we've been updating the dev guide more, including some modeling. I think we're settling and getting the models up to date. The point I wanted to make with this is that OpenStack cookbooks, and while Crowbar's objectives are much broader than OpenStack's, for this release we are laser focused on OpenStack, in part because there is an active upstream community for OpenStack, and because of the work and the people who are doing it, there's, I think, some really good best practices emerging, many of which are based on things that we did in Crowbar, so they're very good fits and very natural fits for us. The practice that we're seeing for attributes looks like this. So I'm in the, let me go up. So this is the OpenStack Common cookbook, which all of the OpenStack cookbooks are using. And in the attributes directory, there is a default RB, and in that default RB, this file is basically nothing but the attributes that the cookbooks, all the cookbooks for OpenStack would use, or at least would have external dependencies on. And that's a subtle point, but it's an important one. So the things in this file are attributes that other bar clamps or other cookbooks for OpenStack would want to consume. So this is effectively your attribute contract page. And so the pattern, there's a distinctive pattern that's being followed that's very consistent, and default settings being laid in that are very consistent. And the idea is that these cookbooks stand on their own. So if you want to run one of these cookbooks, you could literally come in, hack your version of these attributes, and set everything and use the cookbooks without any additional infrastructure. And then what happens is, so in order for Crowbar to work, what we have to do is override these attributes. We don't change them here. We use Chef's overlay mechanism, and so we would inject these same values into the node or into the role so that they would overlay these values with the injected values. So in practice, it ends up being pretty straightforward for us to take these known key values and inject them in the inheritance mechanism so that we can overwrite them. They're still good known values, they still have good fallbacks, they still have good defaults, but it's a very consistent strategy for doing it. And does that make sense? That's my add to Andy's explanation.
There's one question I have regarding this. This points to GitHub ATT Cloud project.
That's correct.
Is it is it somehow related to the ops codes cookbooks that are?
There's a lot of
quite. Yeah.
Good question.
Sorry, Ralph. There's a lot of intermixing, and that's part of the reason that Matt is trying to organize the community to put everything in one place and stop porting them. For example, if you look at the Swift recipe at AT&T Cloud that parse rack space and hours, like you can almost draw a tree of life and see the evolution of I added a little here, you added a little there. So the Swift one I wrote, and then rack space kind of modified a little bit, AT&T modified a little more.
DreamHost.
The idea is to try to bring everybody into the Oxcode community cookbooks and stop porting to them things so we can make faster progress.
Yeah.
So there's definitely a relationship.
That was actually what I was looking forward to. So that we could agree on using the Oxcode cookbooks
Yeah. So we spent the whole day with Matt. Matt came to Boston and Rob came to Boston. We were at Fidelity literally 9 to 6 at Fidelity gave us offices. And they were interested in it. So we spent a lot of the realization that you're hearing was discussed with Matt, who's organizing or leading the obstacle community cookbook site, Matt Ray from Obstacle. So we're trying, I think Rob is trying very hard to make sure we lead the way but not leave anybody behind. So we're trying to get everybody on the same page. I'm sure there's going to be a lot of it at the summit as well.
Yeah. So one of the things that Matt was suggesting, and we should capture here, we're not ready for. Matt suggested using Berkshelf.
I think we were torn between librarian, chef librarian, and Berkshelf around how do you manage the local copy on the file system. And one of them, I think Berkshelf required VV19.
Right.
Maybe that's also a topic for us at some point to decide when we make the jump for the open source. Eventually I will get the right word that I'm trying to say. For the OpenStack build that is SUSE/Ubuntu, we don't really care about Red Hat. We don't want to port the Crowbar product, but maybe we bite the bullet and stop postponing that.
Right. Yeah, I'm hoping we get the 1.9 gem in there this sprint too.
Sorry, the what?
The Ruby 1.9, not gem, it's Ruby 1.9 component. Get that solved.
Okay.
But, yeah, I totally agree. So, and we're just about out of time, but I hope that this helps make sense. So there is specifically OpenStack cookbooks. If we have, we will show up as OpenStack contributors, which I think is valuable, but also I think there is neutral territory for us if we adopt these, sort of bring these together, find out where we are, and we actually make these active because we're using them for deployments, then they will attract AT&T and DreamHost and RCB, Rackspace. They'll start pulling towards this if there's activity. Currently, Matt Ray is cherry picking things and trying to move it into these cookbooks, and he doesn't have much of a test infrastructure to make sure they work. So our use of this as our source for cookbooks could be a very powerful thing for us and also for the community, and would be welcomed. We made sure of that. I'll add one more comment to that. Is part of that agreement with Matt was that we would start adopting the OpenStack Common libraries pattern, which I think we want anyway. It fits Crowbar's strategy.
Well, just to clarify, we actually introduced that pattern to follow up on Ralph's comment.
Correct.
We introduced the pattern and then Rackspace adopted it and enhanced it, and then AT&T took that as well.
Yeah, sorry, it's not new. I'm glad you're clarifying. That pattern is going to, we're going to continue to propagate. How's that, Andy? We'll continue to propagate this pattern, and we have agreement that pattern is acceptable to the people who are doing the upstream, who want to contribute to upstreams.
Could it be documented anywhere, or if it isn't already?
Where would we put recipe level documentation?
That would be in the chef docs. So that would show up in Barclamp Chef. There's a doc section, and then we should have a dev guide under here. Just parallel the tree that you want to implement, and it will automatically merge it all together. But that's where it should be. Does that make sense, Andy? Put a dev guide subdirectory and then put the materials that you want in the dev guide. You could potentially do a dev guide and then
We
chef.
can work offline too.
Yeah.
I can.
It's worth taking a minute because everybody, we really want people to be contributing to the docs. So that's how this works. It shouldn't be that hard or confusing to people. All right. With that, we are out of time. What I would suggest, let me move this out of the way, that for future topics, let's see how we're doing on our topics. Hey, this was here. We still want to do that. We still need to do that. We've done that. We can talk through that, but in planning, I suppose. So the thing that would be worth reviewing in the next one is, I think this is going to move down a little. Data model. I'm assuming people want to see that, and I think it's firmed up enough. Any other suggestions for future topics? Okay. So it sounds like we have action plans for chef structure and install. Please remember to update the Trello board.